In this video, we're going to take a look at differentiating inverse trigonometric functions. Now, for A-Level Further Maths, you need to be able to differentiate the inverse trigonometric functions. And the way that we typically do this is by using implicit differentiation. So there are three standard results that you need to be able to derive. So the first of our three standard results here, this is the derivative of arc sine x with respect to x, and this is given them as 1 over the square root of 1 minus x squared. For the second of our three standard results here, we have the derivative of arc cos x with respect to x, and this is given as minus 1 over the square root of 1 minus x squared. And you can see here this is pretty similar to what we had then for the derivative of arc sine x, so the only difference being now that this is minus 1 over the square root of 1 minus x squared. And then finally we have the last now of our three standard results here, and we have the derivative of arc tan x with respect to x. And this is simply given as 1 over 1 plus x squared. Okay. So these are the three standard results that you need to be able to derive. It is worth mentioning that these are given in the form of the book, but you should be able to derive these results, and you can be asked to do that in an exam. Okay. So how do we derive these results? So what I'm going to quickly show you now is how to derive the derivative then of arc sine x as a practice question. So we'll run through this together. I won't do all three here because the derivative of arc cos x and arc tan x are pretty similar, so I'll leave that as an exercise for you to have a go at. But we will also run through some other practice questions involving the derivatives then of the inverse trigonometric functions. So let's get started then with our practice questions. Starting off with question 1 then, where we're now looking at the derivation of one of our standard results. So what we're looking to show here is the derivative of arc sine x with respect to x is equal to 1 over the square root of 1 minus x squared. So where do we begin here? Well, to start with, I'm going to let y equal arc sine x. So we let y equal arc sine x, like so. Now what we want here is dy by dx, okay? However, in its current form, this isn't possible. So what I'm going to do here is manipulate this equation ever so slightly. And the way that I do that is by taking sine of both sides. So if I take sine of both sides here, well, on the left-hand side, we get sine of y. We get sine y on the left-hand side. And now on the right-hand side here, sine of arc sine x, well, sine of arc sine, they're the inverse of each other, so they'll cancel out. What we get simply left with then is the argument here, which is x in this case. We've got sine y equals x then. And from here, this is much easier to work with because we can now differentiate implicitly. Okay? So if I use implicit differentiation here, on the left-hand side, we get cos y dy by dx. We get cos y dy by dx, like so. And then on the right-hand side, we simply get 1. Okay? And like we said, we want dy by dx. So what I need to do now is divide both sides by cos y. So therefore, dy by dx is equal to 1 divided by cos y. So we get 1 over cos y here. Now, clearly at this point here, we're quite a bit off what we actually want. Okay, so how do we get this required form here? Well, to do that, we need to use trig identities. So we know that, I'll do it over here as well, sine squared x plus cos squared x is equivalent to 1. Okay, what I can do now is rearrange for cos squared x. So cos squared x is equal to 1 minus sine squared x, like so. And then if we simply want cos x here, I need to take the square root of both sides here. So therefore, cos x is equal to the square root of 1 minus sine squared x. Okay. So notice here for the denominator, we have cos y. So in that case, that would be simply the square root of 1 minus sine squared y. Okay. So that's equal then to 1 over the square root. So it's using this trig identity here, then we've got cos y, so that's equal to the square root of 1 minus sine squared y. So 1 minus sine squared y, like so. And we know that sine y is equal to x. If we have sine squared y here, like we've got, well, in that case, then this would be equal to 1 over the square root of 1 minus x squared. Okay, as required, notice we've now got what we want here. We've got 1 over the square root of 1 minus x squared as required. Okay, and there we have it. So that is the derivation of one of our standard results, and that gives us the solution to question 1. Moving on to question 2 now, where we have f of x equals the product of arc sin x and arc cos x. And for question 2 here, we're asked to show that the derivative f prime of x is equal to arc cos x minus arc sin x all over the square root of 1 minus x squared. Well, given that our function here is expressed as a product, it's arc sin x times by arc cos x, to differentiate this function here, we clearly need to use the product rule. Okay, and to do that, we need a u and a v. So it's completely up to you which you define as u and v. So what I mean by that, it doesn't matter whether u is arc sin x or arc cos x. I'm going to go from left to right though, so I'm going to choose u as arc sin x and v as arc cos x. Got arc sin x here for u, and then for v we have arc cos x. Okay. We also need u prime and v prime, so this would be the derivative of u with respect to x and the derivative of v with respect to x as well. But clearly these would be our standard results here. So u prime, this would be 1 over the square root of 1 minus x squared. And then for v prime here, again, another one of our standard results then, we get minus 1 over the square root of 1 minus x squared. Okay. So now, putting all this together then, for the derivative here, using the product rule, f prime of x, this will be given as u multiplied by v prime plus v multiplied by u prime. Okay. So therefore, in this case then, f prime of x is going to be equal, so u times by v prime. So u here is arc sin x. We times that by v prime, which is minus 1 over the square root of 1 minus x squared. Okay, so I put all that together. I'm going to get minus arc sin x. Get minus arc sin x all over the square root of 1 minus x squared. 1 minus x squared there. So that's u v prime. We've now got v u prime. Well, v is arc cos x. U prime is 1 over the square root of 1 minus x squared. So again, we put all that together. So just multiplying these together here, we get plus arc cos x all over the square root of 1 minus x squared. Okay. Now we're pretty close to what they want here. They've just expressed it as a single fraction. So if we do the same here, what we get then is arc cos x minus arc sin x all over the square root of 1 minus x squared. So we just write that down then. We have arc cos x minus arc sin x. And this is all over then, as we just mentioned, the square root of 1 minus x squared. Okay, we've got the exact same here as what we wanted, and this is for f prime of x. Okay, and there we have it. So that gives us the solution there to question 2. Moving on to the very last question now, question 3, where we're given that y is equal to arc tan x squared, and all we want to do here is find dy by dx. Now let me just start by writing down this equation here. So y is equal to arc tan x squared. And we just simply want dy by dx. So how do we find dy by dx here? Well, at the moment, in its current form, this is a bit of an issue because we have the inverse trigonometric function. So to get rid of the inverse trigonometric function here, we're going to take tan of both sides. So in that case, on the left-hand side, we get tan y. We get tan y here on the left-hand side. And then on the right-hand side here, if we take tan of arc tan of x squared, well, tan of arc tan, they're the inverse of each other, so they will cancel. And we get left with the argument here, which in this case is x squared. So we've got tan y equals x squared. like so. And what we can do now is differentiate implicitly. Okay, so if we differentiate implicitly here, on the left-hand side, we're going to get sec squared y dy by dx. So we get sec squared y dy by dx. And that's going to be equal then to 2x. Okay, we differentiate x squared here. With respect to x, we get 2x. Like so. And all we want here is dy by dx. So what I need to do now is divide through by sec squared y. So therefore, dy by dx. So dy by dx here is equal to 2x divided by sec squared y. So 2x divided by sec squared y. Okay. Now, we're not done here because we know that we can use our trig identities here. Okay, we know that sec squared y, do it up here. So sec squared y is equal to 1 plus tan squared y. Okay. So what I can do then is replace this sec squared y with 1 plus tan squared y. So we've got 2x all over 1 plus tan squared y. Like so. Well, we know that tan y is equal to x squared. So if we've got tan squared y, that would be squaring both sides here. So we'd get tan squared y is equal to x squared squared. And in that case then, this would be x to the power of 4. So we're going to get here 2x all over 1 plus x to the power of 4. Okay, and there we have it. So that is dy by dx there, and that gives us the solution to the very last question, question 3, and that actually brings us to the end of this video on differentiating inverse trigonometric functions.